All right, we are going to look today at different kinds of experiments and things that are good and bad, advantages and disadvantages of sort of the way you design an experiment. So, first of all, you need to know some vocabulary here. Some what looks like experiments are actually observations. They're ones where you watch, you record, you don't interfere, you don't assign people to a treatment group, or impose a treatment on them at all. Then there are one-track experiments, and that's where you do impose some sort of a treatment on people, but every single subject gets the same treatment. And then there are experiments where different randomly selected groups get different treatments. So you have to have at least 2 treatments in order for it to be a typical experiment. If everyone gets the same treatment, then it's a one-track experiment. All right, just kind of, we've looked at this before when we did the different kinds of causation, but just remember that the explanatory variable is the cause, it's the treatments that are imposed. The response variable is the effect, it's the what you're measuring, and then obviously those third-party variables out there, the lurking variables, or sometimes they're called confounding variables, are also part of experiments. Okay, here's just an example. This is an experiment, if you can tell, about if the amount of exercise that you get affects your weight, and clearly probably the amount of exercise you get does affect your weight. So the explanatory variable is the exercise. The response, or what I'm measuring, is people's weight. But clearly there are other things out there too, like your diet, your metabolism, what type of exercise it is, lots of other things that certainly would affect your weight as well. All right, then some other vocabulary that you need to be familiar with. A placebo is a fake or a dummy treatment with no active ingredients. It's used as a baseline for comparison. You've probably heard of sugar pills. That's an example of a placebo. But anything that looks and acts and whatever exactly like the real thing, but it's not the real thing, would be called a placebo. Okay? Sometimes what happens when you give placebos, even though people are getting a fake treatment, the results are that they get better anyways. And sometimes that's just because they feel like somebody's taking care of them and they're doing something about whatever is that's ailing them. And all of a sudden they feel better, even though they're really not getting any active medicine, they're getting fake medicine. Sometimes they feel better anyways, and that is called the placebo effect. I like to call it the kind of the mind over matter effect. Both observation and one-track experiments often yield useless data because of confounding or lurking variables. Okay, so when you do that, when you do observations or one-track experiments, your lurking variables are not controlled very well, and that becomes a big piece in when you measure your end results. Okay. So the first goal in designing an experiment is to ensure that it will show us the effect of the explanatory variable on the response variable. And to do that, you want to do a randomized comparative experiment, and that is one that compares 2 or more treatments. Here's an example of a randomized comparative experiment. I started with 200 males. I broke them into 2 groups evenly, and they were randomly assigned. Okay. In treatment 1, those males received vitamin C. In treatment 2, those males received a placebo. Those were the explanatory variables, whether they received vitamin C or the placebo. And then in the end, I was going to look at how many colds those males had, and that would be my response variable, or what I am measuring. So you always want to have a control group. Sometimes it's a placebo group. Sometimes it means one group gets the real thing and one group gets the fake thing. But a control group does not have to be given a placebo. A control group might just be given a different treatment. Like I might give one group vitamin C and look at their colds, and I might give one group some other herb, or a different kind of vitamin D or another herb or a whatever, and then look at their colds. So it doesn't have to be a placebo group per se, but it has to be a group that gets a different treatment. And this does help eliminate some lurking variables. And then another couple vocabulary words here. If you do a blind study, it means that the subject does not know what treatment they are receiving. They don't know if they're receiving the real treatment or the placebo treatment. And then double blind is that neither the subject nor the administrator, meaning the person actually giving the medicine, know what treatment is being given. Obviously, someone in part of this study has to know who's getting what, so there's some like secretarial kind of person that knows, but the actual person administering the care to the subject does not know what treatment is being given. This is important because if people know what treatment they're being given, then they are likely to treat them differently. And so they might go, oh, well, whatever. You're getting the placebo. Huh, I don't need to worry about you. Here, quick, take your medicine, be done. Where if they think there's even a chance that you're getting the real thing, they might be really hopeful that it works and go, oh my gosh, yep, you're getting the real thing. Let's take good care of you. Let's hope this works. How are you feeling? Whatever. And some of that TLC piece is important to this. And so because of the placebo effect and because of the different care that you might receive if you knew whether you were given the real thing or not, excuse me, it is important that it be for sure blind and preferably double blind when you do experiments like that. All right, so here's some experiments that we're going to look through together, and we're going to just kind of talk about some different parts of them, okay? So the first one is about the leg muscles of men between the ages of 60 and 75. And they did a study, and they were between 50 and 80% stronger after these men participated in a 16-week high-intensity resistance training program twice a week. Okay, so is this an experiment or an observation? And this particular one happens to be an experiment. And the reason it's an experiment is because a treatment was imposed on them. They were told that they had to go to this exercise program twice a week. So because treatment was imposed, it is an experiment. However, you need to know that this is a one-track experiment because every person in this group was given the same treatment. They all went to the same 16-week high-intensity resistance training program, every one of them. So it was an experiment, but it's a one-track experiment. So the explanatory variable in this case would be the training program. That's what the people were given. And the response variable, what they were measuring, was their muscle strength. Okay. Are there any confounding or lurking variables in terms of what else would affect muscle strength besides this 16-week high-intensity program? And certainly there are some other things out there. Things like what diet they have. Do they eat a lot of protein? Stuff like that. Their general health condition. Let's see. Other activities that they do. Are they a person who's active in other ways or not, or whatever? We don't really know. Okay. The subjects in this case, the people that participated in the study, were men aged 60 to 75. And was it blind? No, this was not a blind study. Obviously, these men knew that they were participating in it, and so did the people that were caring for them. It would be pretty hard to do a blind study like this. So, no, it was not, because the subjects knew. Okay, so there's one example. We'll look at a couple of these. Here's another one. Among a group of disabled women ages 65 and older who were tracked for several years, those who had a vitamin B12 deficiency were twice as likely to suffer severe depression as those who did not. So on this particular one, they didn't give them any treatment. They didn't assign them a group. They didn't assign them a task to do or a treatment to get or a medicine to take or anything. They just looked at these women and measured their B12 and then determined if they had depression or not. So this is an observation because no treatment was imposed. Okay. The explanatory variable in this case would be their B12 level, that vitamin level in their body, vitamin B12 level. Okay. The response variable would be whether or not they suffered depression. That's what I'm measuring. Okay, and then are there other confounding or lurking variables out there that might cause someone to have depression other than their vitamin B12 level? And certainly we know there are. Things like their general mental health. Um, do they have anxiety? Things like that. So their general mental health. Certainly life events, things like have they had major, a death in the family or, you know, lost their home or whatever. Life events, lots of things that would affect depression other than simply whether their vitamin B12 level was off or not. Okay? So the subjects were women age 65 and older. That's who I'm looking at in this case. And again, was this blind? No, this was not. Women knew there was no treatment imposed, so it was not necessarily to be blind, necessary that it was blind. Okay? All right, one more here. Is diet or exercise effective in combating insomnia? Some people believe that if you cut out desserts, it can help alleviate the problem, and other people recommend exercise. So there's 40 people that volunteered who have insomnia to participate in a month-long test. Half of them were given no desserts, the other half were given desserts as usual, and then half of these people in each group were randomly assigned to get exercise or not exercise. And those who ate desserts and engaged in exercise showed the most improvement. Okay, so is this an experiment or an observation? This is definitely an experiment because treatment was imposed. They were given an assignment as to which group that they would be in. Okay, the explanatory variables, in this case there's two of them. We are looking at both diet and exercise as a cause for the response variable, which would be insomnia. We're going to measure their insomnia levels, I guess you would call it. Okay, are there other confounding or lurking variables that affect insomnia? Whether people have insomnia or not, and certainly yes. Things like have they drank caffeine? What's their stress level like? The list can go on, but there's a couple. Okay? The subjects in this case are insomnia sufferers, and there's 40 of them. Okay? And was it blind? No. These people knew exactly which group that they were going into, so no, this was not a blind study. And if we were to diagram it, it would look something like this. So I start with 40 insomnia sufferers. And I randomly assign, and I take 20 that have to cut out dessert. And then I take 20 of those who eat dessert still. And then in this group, half of them, so 10 in here, have exercise. And half of them don't have exercise. And then the same thing down here. I split that group in half. And half of them get exercise. And half of them do not. In the end, all of these cases, I am going to measure their insomnia. Okay? All right, and one last one. Scientists at a major pharmaceutical firm investigated the effectiveness of an herbal compound to treat the common cold. They exposed each subject to a cold virus, then gave him or her either the herbal compound or a sugar solution known to have no effect on colds. Several days later, they assessed the patient's condition using a cold severity scale from 0 to 5, and they found no evidence of benefits associated with the compound. So this was, again, definitely experiment because treatment was imposed. That treatment would be whether you got the herb or the compound. Okay, so again, the explanatory variable would be whether you got the herb or the sugar solution, the herb compound or the sugar solution, I should say. Okay, The response variable would be what you're measuring, and in this case, my response variable would be the severity of my cold. Okay. The confounding variables, what else would affect whether you get a cold? And that would be things like rest, diet, exposure to other colds, other medicine you might be taking, your general health condition. The list could go on, but there's a few. Okay. Subjects, it really doesn't tell us. It does not specify who our subjects are. We don't know if it's young people, old people, men, women. How many of them are there? We don't know. Was it blind? It doesn't say whether it was blind or not, but I'm guessing it probably was. Typically when there's a placebo thing, it is blind, but it really doesn't say. Okay, and then lastly, we're going to diagram that study. So, what we're given here is patients that are exposed to a cold. That's all we know about them. We don't know whether they're young, old, female, whatever. We don't know. Okay. Some were given an herbal compound. And some were given a sugar solution. And again, this would be randomly assigned. Okay. And then in the end, I'm going to assess the patient's cold condition, or the cold severity. Okay? All right, 3 main things you need to know about whenever you do an experiment. Really, really, really important things. The first thing you have to do is you have to control your lurking variables as best as possible. The easiest way to do this is to make sure that you use two or more treatments. If the placebo makes sense in your situation, use it. Okay? And next, you need to make sure that you randomly assign your subjects. Very, very important that it's randomly selected and not self-selected, because that can definitely sway results one way or another. And the third thing is that you need to make sure you use enough subjects to reduce chance. So, if you only have 30 people in your study, the results that can be generalized to, or the chances that can be generalized to the major population is pretty small, okay? Whether if you use 500 subjects, the chances that you can generalize that to the main population is a lot higher, okay? Margin of error, we've talked about that. All right, and certainly the goal is to make sure that your results are statistically significant, meaning the differences between the treatment groups are so large that it's unlikely that they are just due to chance, okay? If you have statistically significant results, you can be more confident in your conclusions. So if the difference between one treatment and another treatment is only 5% different, that's not big enough. But if it's 30, 40, 50% different, then I know it's probably because of the treatment and not some other lurking variable out there or chance or whatever. Okay? So hopefully this has helped.